Well, my name is Robert Clegg. I'm with RMF Engineering. This is Travis Campbell I brought with me today. We're going to be presenting on retro commissioning of laboratories. Thank you for having us. We're really excited to be here. Pretty excited our abstract got accepted, and we're here to present for you folks. I hope you enjoyed the presentation. Quick synopsis. Essentially, what we have done, we're out of our Raleigh, North Carolina office, and we did retro commissioning. We did 2 big research laboratories on major universities. We're gonna talk a lot about what we did, the approach, some of the details, things that we found, stuff like that. We're not gonna talk about the university specific because, well, a couple things we found are a little embarrassing. So they said, go ahead and talk about them, but don't really talk about us. So essentially, we went into 2 great big research facilities, 100,000 square foot. We're gonna talk about the details, why they're similar. It was like, we did one research facility, and then right on its heels, we were asked to do another one. We went in and did our investigations to see what was going on with these facilities and why they weren't working that great. We're going to talk about the retro commissioning process, how we applied it, and a lot of our findings. Our learning objectives, if you haven't read these already, it's kind of like what I just went over, but we're going to talk about laboratories themselves, the kind of facilities we were into, what compromised these facilities, how they got to the state that they were at, talk about the retro commissioning process, and again, our findings. And then we're also going to introduce ourselves a little bit, talk about our company for a slide. So this is our agenda, intro. We're in the middle of that right now. We're going to talk about why we had to retro these facilities, and we'll probably see this kind of stuff again. Maybe you've seen it already on other similar lab facilities and universities, why this happens. Design considerations, why we had to take it back to design, and you can't just go in and fix things in the design. A lot of times we find issues there. The process that we applied, how we got bang for the buck for our clients, how we served them and met their specific needs, a lot of the results, some of the things that we found, and then that's going to pretty much wrap things up. So a little bit about us real quick. We are RMF Engineering. Pretty good size. We're 13 offices up and down the East Coast. We've got just under 300 folks working for our company and growing. And we're happy to celebrate this, our 35th year anniversary this year. We've been in business 35 years. We're excited about that. We offer a wide range of services, not just commissioning. Commissioning is part of what we do. We do design, infrastructure, master planning, and we commission all of the above. So that's enough about that, and now let's talk about our projects.
So the first thing you want to understand is why. Why do these facilities need to be retro commissioned so much more often than your standard facility? And that includes office buildings, but it also includes standard lab facilities that are not research facilities. In these research entities at these universities, you have a lot of tenant turnover. You have your researchers come in, and they're on like a 4 or 5 year grant to do their research. And if they make their research, then great, they get to keep going, they get to keep researching that topic. But if not, then the university is going to find somebody else. And what happens is this turnover happens every 4 or 5 years, and whenever you have a new tenant come in, they kind of want to outfit the space. It's their space. They want to do what they want to with it. And they might add a fume hood, they might add a bench exhaust. And what the problem with that is they don't take a holistic approach. They look at their one specific lab. They're not looking at the whole building, how it affects the air handling equipment, how it affects the exhaust fans, how it affects the fume hood right beside it in the very next lab. A lot of times when we come in here, we have 0 diversity left on the system, and that's exhaust fans and air handlers. There's absolutely no more diversity, no more room for expansion. And a lot of times we're called in because they want to expand. So we're telling them, no, you can't do that without changing the actual major equipment. And these 2 lab facilities, they have a lot of things in common. They're both over 100,000 square feet. They served a lot of the same entities, teaching, research labs, staff, faculty. All these different entities come into these things. And the first why is actually what I just covered with the turnover. Your tenants come in, just like I just said, they turn over, and you have a lot of problems holistically that are not always captured. The next actual why is going to be the controls. You have extremely complex controls in these spaces that have very low tolerances. Typically as commissioning agents, we hold office buildings and your standard air handling equipment to roughly 10% tolerance between what we're actually reading with the tab guys versus what BAS says. In a lab space, we don't have that luxury. We usually hold them to 5% or less. So when you're working with such low tolerances, any kind of little dust particle in that flow ring can mess up that flow. And small changes make great sacrifices, I guess you would say. If you're 5% off on the low side and 5% high on the high side, you're talking a 10% swing there, and that affects your air change rates, it affects your building pressure or your room pressurization. All that is affected. So you also have yearly fume hood calibrations that take place. They're looking at sash height position, make sure that we're obtaining that 100 feet per minute face velocity that we want to get. And a lot of times what happens there is that's done by the university itself, their EH&S or however they want to pronounce that entity. They come in and they look at it at 18 inches, make sure you're getting your 100 feet per minute. But they don't look at it on the low side. And what we find when we come into these facilities a lot of times is, that low side, the valve is not actually setting back. So BAS might think it's doing, 100 feet per minute still on the low side, but since it's getting 100 feet at 18 inches, you're looking at 500 or 600 feet per minute going across that low side when the hood is actually closed. And that is affecting your air change rates again, your room pressurization. I think we'll move on to design with Rob.
So these things really, they build. So you're coming in every year, they're coming in. The environmental health and safety people are coming in, they're recalibrating the fume hoods. They're not looking at the flow rings and whether they're measuring accurately. They're not taking airflow rates on things. You've got you've got device drift and everything's going out of, and after years and years of this compiling and everything, pretty soon you're pretty far out of whack. So now, yes, your air velocity is measuring correctly across your fume hood, and that's fantastic. And you're meeting your air change rates when your fume hood's wide open, that's great, but your BAS has no idea what the actual airflow is doing, and therefore it cannot control the general exhaust or the supply air to make your pressurization. So what we typically find is that these things are quite a bit out of whack, and you come in and you're not getting pressurization. It's when you start to really have a lot of pressurization issues, or your supply air can't keep up and you can't maintain your temperature and your humidity control, that's when they call us in, but that's several years down the line after this is compounded for so long. And so here again, design considerations. What's happening in these labs when they're turning over, they get a new grant, their new research project, well, they need a new facility. And in these old laboratories, a lot of times we see labs that are not intended for a certain use, they're retrofitted to accommodate that certain use. And sometimes they're trying to make a BSL out of something that was not intended to be a BSL lab, and they just kind of barely squeak by and meet the criteria and everything, but it's not really working well. And sometimes we'll come into a lab that was a BSL and it's been switched back to something else. But we've got all these different types of labs, different things to consider. We had one lab we went into with nuclear magnetic resonance. We had like a dozen NMR labs, and they're all different, because all the equipment's different. Some of them have really good shielding, and you can get right up to the equipment, no problem. Others have terrible shielding, and you gotta stay back 10 to 20 feet away from the equipment. You just don't know what you're gonna get coming into these labs. We had an electron microscope. They were having problems. They kept frosting over. It was building up a lot of frost, and they're trying to control the humidity. So how are they controlling the humidity? Well, they dropped in a crack unit, and they dropped in a fan coil unit, and we're trying to dehumidify. So when they asked us to come and take a look at this lab, we walked in and we're like, when you got your door propped open, you don't have an air room, the whole building is a little humid, you're trying to dehumidify the entire building with a crack unit. Yeah, you're not gonna be able to do that. You're gonna continue to build up this moisture, so we gotta put closures on here, we gotta seal the lab, and then we've gotta continue to try to drain that humidity out of the room. But it's just uncanny. Some of the things you come across, it's pretty low-hanging fruit that you find sometimes. So again, design considerations. We're working in a research lab that's got all these different things like Travis is talking about. So hypothetically, we come in and there is a research lab right next to a teaching lab where the research lab has 1 or 2 fume hoods, and the controls are pretty simple because everything's controlling off of those fume hoods and tracking, and everything's working fine. But right next door, you've got a teaching laboratory with a dozen fume hoods, just like our controls are showing right here. Well, the dozen fume hoods, plus some snorkel exhaust, plus a bunch of benchtop exhaust units, everything's on switches, everything, shuts down, energizes. The teaching laboratories oftentimes have night setback because they're not storing chemicals in those fume hoods. They're storing chemicals in the research lab fume hoods. So they try to do nighttime setbacks in the teaching labs. Well, what happens when your diversity is gone and you're adding these facilities, you're changing your research lab, and you've got a classroom with hoods swinging open all day long, and next door you've got a research lab and the fume hood's going into alarm 20 times a day because it can't meet the velocity, the airflow keeps changing. So these are issues that we come across when we have these different facilities all put together. And Travis also mentioned the complexity of these things. We're not talking about terminal units anymore. We're not controlling with dampers, we're controlling with air valves, where we've actually got a plunger going into an orifice and controlling our airflow. And there's not necessarily a sensor reading that airflow. It's calibrated, and it's factory calibrated, but it's factory calibrated 10 years ago or 20 years ago. We don't know. We're coming into something that's been around for a while. And sometimes these factory calibrations aren't even legitimate. A lot of times, they are legitimate, but they come in and the duct work and the layout and everything, there's a system effect. So just because the valve came from the factory calibrated, doesn't mean you don't have to test it when it's first installed. And now here we are years down the road. Well, we want to test it again, see what it's actually doing. So we've got all these different things, all these to consider when we're doing this. We've got different types of equipment. We're going to talk about the strobic fans a little bit. We're going to talk about the upblast and the bypasses and all these things and how they can affect a lot of things going on in these labs. And here's what I was just talking about with the valves versus the terminal units. One of the laboratories we went into to work on had a retrofit where the original air control was all terminal unit, all done by damper. And essentially all they had done was remove the pneumatic controls from the existing terminal unit, and they slapped DDC on top of it. Okay, well, we can make that work, but getting within that 5% tolerance is going to be very, very difficult. And so it took a lot of tuning and control work, and we had to clean all those airflow sensors they're trying to reuse. But that's that kind of thing that, they wonder why they're having problems, and it's a little bit obvious to us when we get in here and start doing this. And then you have your overall air handling units and your exhaust fans, and we're coming into these labs, and again, it's mixed use, so you've got to be careful on how this is working. One of the labs that we did was 100% outside air, despite the fact that they had big lecture halls and a lot of office and administrative spaces, and they could really use a lot of return air. The other one had return air, and we're going to talk about some issues that we found where they were renovating spaces and taking administrative spaces, turning them into laboratories, and I'm sure they intended to, but they didn't actually patch over the return air ducts. So they've actually got return air going back to their air handling units from active laboratories. So this is the kind of stuff that we find when we're going through here, and it's really easy to come across some of this stuff.
So getting into the CX process a little bit, one of the biggest tips that I want you to take away from this is communication. Communication is key on these projects. The people that you're working with, the researchers, it's very tricky to get in their spaces and work with them. They don't like people coming in. It's not that they're bad people or anything. They just don't like people messing with their stuff. They have, like I said earlier, they're working on these grants. They want to get their stuff done. So they have very high-stress jobs. They work long hours. A lot of them are 24/7 from what we see. And they have these sensitive experiments that you can completely ruin if you knock over the wrong thing with your big flow hood or whatever it is that you're using. So it's very tricky getting in there. So one of the first things that we do to mitigate this is make sure that we have the right players at the kickoff meeting. I like to have the owner's PM, which usually works for facilities. I'll have the facilities managers there. Some guys from the control shop typically come. And then also the heads of the departments that are in these facilities. So like Rob said earlier, one of these was a bio and chem kind of combo deal. One of them was solely chemistry. So we want those departments heads there with us. And what those guys can do is they come in, if you get buy-in from the department heads, you're getting buy-in from the whole building. They all work for this head. So if they're on board, then everybody else is too. And they can also, Rob's also talking about some of the hard spaces to get into, the BSL-3s and the BSL-AGs and the NMRs and all that. The heads will tell you where those are and the type of working conditions you're going to deal with going in there. They're also going to tell you hours. A lot of these facilities, like I said, work 24 hours a day. So if there's a space like that, they're going to tell you where those spaces are. They're also going to know anything about any kind of hazardous chemicals that you might run across, any kind of hazardous work environments. Some of these laboratories, they work with staph infection a lot, so you don't really just want to go barging in there. But they're going to be able to tell you all that kind of stuff. Next, after the kickoff meeting, we want to do a thorough walkthrough with the owner's PM. He typically knows all the players in the building. He's been in there, and he knows all the guys, and he'll be able to introduce you to those guys. You're not just, the first time that these researchers see you is not when you're dragging this huge flow hood in. They've already met you, and when you're doing this, you want to really talk to everyone, be personable with everyone, say hey to everyone, ask them how they're doing. A lot of times our soft skills get overlooked in this industry, but they're extremely important in working with clients like this. And then also another thing I like to do is post schedules like you see here. In the break rooms, I'll print these up and I'll post them in the break rooms, I'll post them in the mail rooms. And these are not I'm going to be in this lab at this time of day. These are a broad overlook. So it says, I'm going to be in this wing of the building on this floor sometime this week. And what that does is it gives us flexibility to move about the building where we need to. And it also gives the tenants an idea of where we're going to be. So no one's really questioning, oh, they're going to be in my room this day. They're saying, oh, they're going to be in my wing this week, and they might be in my room tomorrow or the next day or something like that. And we find that typically works the best. Another thing we like to do is Monday morning meetings, just quick updates every Monday to give the owner's PM and the client where we're going to be, tell them how things are going, give them any kind of issues, updates, anything like that, the kind of stuff we're finding. Also, occupant surveys. We shoot those out early on in the project, and what those are doing, typically 17 to 25 questions. If you send a bigger survey than that, most of them don't really like it. They don't want to spend an hour doing this for you. They want to spend 5 minutes. So keep them short and simple. Ask things like any kind of weird smells or any kind of fume hood problems that you might be having, any kind of chemistry, chemical restraints that you might have, temperature restraints. All that kind of stuff is housed on those occupant surveys. So after we've done the walkthrough with the PM, it's time to get in and start looking at the equipment. First things you're going to look at, of course, overall condition. I don't know how good y'all can see these pictures, but that up there is a cooling coil that was abandoned in place, so a reheat coil, I'm sorry. That was abandoned in place. It was an older VAV that they abandoned, put newer DDC controls on after this. And what had happened was the building was built back in, I think, 54 or something like that. And the ductwork was internally lined. So all this insulation had been blown down this ductwork for the past 60 years. It hit that 160-degree coil and just melted. And we measured, I think it was like 2.5 inches of static pressure across this thing. So they put in all this brand new equipment. They're like, oh, why am I not getting my flow? They couldn't figure it out. So easy stuff like that you can find on your initial walkthrough. Rob was talking about the actual ductwork layout. You can see there's a fume hood with this duct doing all this snake motion here. And it's impossible to get a good tab rating on that. You're never going to be able to. So, the best you can do is the best you can do. And typically your client, of course, is not going to go in and completely rework all their ductwork, but it's still a suggestion saying, it's hard to get a good reading on this. Also, things like bad insulation. A lot of this is original back from the 50s, soaking wet, saturated. And then there's one of those return coils that Rob was actually talking about earlier. In the lab, I think we found about 12 of those throughout the entire space. And things you can do here, make sure that the intent still meets the space. So a lot of times we come in and we see these areas, and they might have been office space areas in the beginning, but now they've got 5 or 6 sub 80 Celsius freezers in there and just rejecting all this heat, and the cooling just can't keep up anymore. So things like that to look for when you're doing your initial walkthroughs. You can do this even with the walkthrough with the PM. A lot of this is low-hanging fruit. And if you can point this stuff out to him as you're going through, it really gets him, excited about his project. So to understand the actual testing parameters that we want to be testing for, you need to understand the actual system and how it's going to work, the sequences. So as Rob was saying earlier, typically in these labs, the exhaust drives the entire lab. Most of the time that's your fume hoods. That's where most of your CFM is going to be going. So everything else tracks that fume hood exhaust most of the time. When fume hood is open, supply valve is also open to make up for all that lost air. General exhaust typically goes to minimum position. And then your snorkel and your bench exhaust, there's typically manual switches for those, so your supply valve will usually make up for those on its own. When you're going through and looking at these labs, an absolute ton of data is gathered. We test these, so we're not tab guys. We're not coming in and tabbing this facility. We're doing what we call a performance check. So we want to make sure it's performing the way it was intended to perform when it was designed. We're not making sure the box can meet maximum. We're making sure it actually works the way it's supposed to work. So when we go in and we're looking at all these different parameters, we're testing in 4 scenarios. We're doing a minimum exhaust, a maximum exhaust, and a cooling and a heating mode. And you're going to get all this information in each and every scenario that you're testing. So you're looking at flow rates, you're looking at temperatures, you're looking at pressurizations, all that stuff in every single scenario. So it's very easy to miss data, and you don't want to miss because then you have to go back in that lab later, and that's just going to make everybody else mad. So make sure that you have a plan of attack when you go into these labs. Make sure that you know what you're after, that you're going to get it, and that you have it all before you leave. You want to be in there once and be done with it. Another thing I like to do in this phase is the controls here. So I did controls for about 4 years before I came on board with RMF. So I like to pull down these control diagrams and really dig into those and look at those guys and see what's actually happening. A lot of times the controls contractor will come in and just drop his factory PID loop in there and not tune anything. Well, that works in most cases for your office spaces and such, but in these types of facilities, we don't have that luxury again. So we want to make sure that we're actually getting tuned PIDs to really control this stuff the way it should be controlled. That's very valuable to know. Also, in these labs, there should only be 2 or 3 different controls scenarios per a laboratory facility, depending on the actual equipment that's in that lab. A lot of times with these partial upfits that take place, you have different controls contractors coming in, and you might have a whole different sequence, even though this lab matches this lab exactly the same. You want to make sure that those control sequences match each other. That really makes it easier on the owner's control staff, so that's another thing that we're checking for here.
Yeah, it's not uncommon for us to come in and find that when we're doing these one room off, one lab off renovations that have been done over the years. One of these labs we did had more than 20 renovations, just single lab at a time. And we come in, we look at the block diagrams, and the controls contractor is the same controls contractor that did all the original work. Schneider's coming in and working on Schneider, et cetera. But you've got a different tech, and these guys kind of like to reinvent the wheel a little bit. They come in, they know what they're doing and everything, so they might look at the existing block, they might just grab it, copy, paste, but a lot of times they don't. A lot of times they start from scratch and rebuild their own, and what we end up with, 20 renovations and a dozen different sequences for the exact same room setup. And so, we've got one O&M staff for this whole building. We don't want 12 different sequences. We want one sequence consistent over and over and over. So this is a great opportunity to go in, look at those block diagrams, see exactly what every single lab's doing and why and how, and go back and get those corrected.
So this is one of those facilities. This one's actually in a coastal environment on the coast of North Carolina. And they kind of had an architectural standard on their campus. They didn't want big strobic fans on top of their facility. They wanted everything in their penthouses in the attic space of the actual buildings. So what they had were these huge, almost air handler-like exhaust fans that they used to actually do their lab exhaust in these enormous stainless steel stacks that came up through the ceiling and blasted out the top of the building. I want to say they were about 7 foot in diameter. They were enormous. And when we got there, they had no tab holes drilled in them at all. They had never been tabbed before. No one ever got a velocity reading on them or anything. So that was one of the jobs that we had to do, and we were up there and found out that the stuff was like a 1/4 inch thick, and I think we made like 3 trips to Lowe's to get the right drill bits to get through them, but eventually we got through them. But yeah, it's uncommon that we typically get to work in environments like that, but doing these lab retros, it invites that kind of thing, and it's really fun to get to troubleshoot in those strange environments and such that not many people get to work in. This is actually the same exact exhaust fan that you just saw in the last slide. So they have a constant volume fan, but of course your hoods are variable volume with their sash heights. So what they did was they opened up this bypass in the attic space in that penthouse to bypass that air so they still maintain their discharge velocities on their fans. And the reason we were called in out here is actually because they had a rain event in the building where it was literally raining down on the occupants. The ceiling tiles would get saturated and it would actually rain on the occupants. And this wasn't like one lab doing it or anything. This was like the entire building doing it. And it did it like twice and it would just instantaneous start raining. It was insane. But yeah, so they called us in to look at everything, and one of the first things that we noticed were these huge bypass dampers, and what it was doing was sucking in all this air from the outside in this coastal region, and there was actually no vapor barrier between the attic space and the second floor. So all that humid air was just allowed to leach straight down into the drop ceiling space of the second floor and just condense on that ductwork. And before we actually got there, they hired some controls contractors to look at it, and all they did was turn the air down to like 44 degrees, so it just made the problem worse. But you have to kind of take a holistic approach on some of these jobs. You're not coming in because your owner says, oh, it's time to retro commission that building. You're usually coming in because they have a problem like this that they want you to look at for them. So you have to kind of look at the building as a whole to really determine what's causing your issues.
This particular lab, when we got called in, it was just a kind of a calamity of errors coming in. We got there and they explained to us what was going on, let us know that there was a controls contractor working on it, and they were going through the labs trying to figure the labs out, and we just said, well, I don't think this is a lab-specific issue. We think this is a holistic issue. Let's take a look at your air handling units and your exhaust fans, and this building was 100% outside air. So, the first thing that they told us, we've already got, we're in dehumid mode, and we're subcooling our air down to between 45 and 50 degrees. And we're like, wow, that's really cold, okay. So you think that all of this moisture is coming in through your outside air. And they did. And so we looked a little further and looked at these exhaust fans and found these bypasses, and what they were doing is they're drawing, first they're pulling a huge negative on the penthouse, drawing in all this moisture, but then they're also not getting their setbacks and their fume hoods pulling more negative in the lab spaces than they were trying to get. Ultimately, the whole building was incredibly negative, and a lot of it was in the stairwells coming from the penthouse. So, we went through and did an analysis of the airflows, where everything was coming from, pressurizations, and we stayed out of the individual labs. And we came back and said, look, what you're doing is you're pulling in all of this moisture through your building envelope, through your doors, through your penthouse, and it's not enough pressure to be obvious and swing doors open everywhere, but you're bringing in so much moisture and you're so negative that when it gets really, really humid outside, you're bringing this indoors, and then you're compounding it now because you've got your ductwork is 45 and 50 degrees. So every ounce of that moisture is condensing on that ductwork, and it was literally... The first thing they did once we got this under control, which was like 2 days later, we told the controls contractor, fix this. They went and did it, and the next thing they did was bring a contractor in to change out 100% of their ceiling tiles. Yep. Because they were all ruined.
I think they did that twice, actually.
Yeah.
So one of the last tools I want to talk about in the process is trending. So this is huge for us. We typically get access to the BAS as soon as we can, and we'll start setting up these trends to make sure that we have every piece of data that we want. We usually trend them as labs individually. Like you see here, this is a complete lab. That's every valve in the lab, and things that you can find here very easily just by setting up these trends is like the green line there. All those green lines are fume hoods, and you can see that they're not setting back at all. That tells me that those sashes never move position over the course of that 5 days, which obviously not the case. So this is just another tool that we like to use because we can't be there all the time, of course, but we can really look at the building all the time, see how it performed last night when we weren't there. Trending is very valuable. We'll typically wrap these up. I'll annotate them, and we'll include these in the deliverables at the end of the project.
So with that, deliverables, that's kind of how we want to wrap it up. What is it that they're getting? What are you doing for your client? And what are you trying to get out of this whole thing at the end of the day? We generally follow ASHRAE, Guideline 0, do all the deliverables that we need to get done, but what we really want to do is we want to give our clients bang for their buck and figure out what it is that they want to get out of this facility. For example, the facility with the so-called rain event. They wanted it to stop. So, we wanted to get in there, figure out what's going on, and fix that for them. But afterwards, they wanted us to continue on and see what else was going on in the facility, and we continued, and we did 100% testing of that particular facility. We did go lab by lab by lab after we commissioned the air handling units and the exhaust fans and everything. And so these are the deliverables a lot of times you're going to do. We're going to look at the design review, see if we can figure out what's going on from that. We do our Retro CX plan, CFR. We do very detailed test forms, just like if we're doing regular commissioning, like a new construction commissioning. We'll do investigation forms like installation checklists, a lot of times on a lab-by-lab basis rather than like a PFC for a terminal unit. But we'll do our test forms, and we do those in detail. We've got some examples. We do an issues log. We want to list out the issues, but then we also do the ECMs, energy conservation measures and FIMs. We'll talk about those facility improvement measures, and a final report. And most of the time what we do when we do all this stuff, we'll pull it all together, but then we'll do a presentation, because a lot of times we're dealing with project managers and clients and some higher level folks that want to know what they're investing, why are they putting all this money into these improvements for the facility, and we've got to, we're engineers, and we talk tech, and we come in and we talk circles around this and hydronics and everything else, and it's not their jam, so they need us to break it down and make things simple for them and explain to them why this is going to really benefit what they're doing. Actually, this one thing, I don't know if you guys can see it, but one of these is a single line diagram where we had about 8 pages of this for one of these laboratories, a 9-story laboratory, and we just did a schematic of the entire thing. And they loved it because they could see exactly where all their air was going, where it was coming from, just a great big riser schematic. One of the deliverables we did. And then this one right here is just simple red line drawings. So it's amazing how simple a deliverable can be and still be extremely valuable. Like Travis said, one of the first things that we do when we get into the facility is we do our investigation. We start walking around and looking for things and seeing how things are laid out. Well, we have to do that because we've got 25 different renovations in a building, and we've got to pull these things together and figure out what is actually installed. Where's our ductwork routed? Where's it coming from? What's serving what? And so as we're doing that walk-through investigation, we're popping tiles, looking at the layout of everything, and we're drawing it, and we're marking up the as-builts. For one of our facilities, the first thing we did was take all of the as-builts from the renovations and try to consolidate into a single set. And then we took that into the building as we walked through, and we marked it all up, and we redline it. Well, what's really cool is, yeah, the red line's valuable, and they like that and everything, but once you have it to this detail, most clients have everything in CAD already, and they can give you the CAD drawings, and it does not take much to convert that to CAD. It's actually pretty cheap. So that's a really cheap, quick and easy deliverable that the clients love. Now they've got a full set of as-builts for this 50-year-old facility that includes every renovation that they've done. This is just low-hanging fruit, really easy stuff. We're doing the investigation, the walkthrough, and what do we find when we go to the cooling coil and the air handling units? These massive bypass plates down at the drip pan, they're just gone. Completely corroded, eaten away, laying in the pan itself, and you've got tons of air just bypassing the chill water coil. So, and then here on the right, we've got outdoor air plenums. Top's what it's supposed to look like. Outdoor air plenum's supposed to be sealed, but we found when you climb up on top of the unit, you wouldn't have seen it otherwise. Nope, just open to the mechanical room. Just drawing in air, and the mechanical rooms aren't sealed, so you're pretty much pulling air from your facility through your door into your mechanical room and back into your unit. And the client's trying to figure out why they've got this negative pressure across that door. Thermal imaging is really cool. We get in there. A lot of times we'll hire a building envelope commissioning agent to do some of this for us if we really think we've got a lot of issues with the building envelope. But sometimes it's just easy enough to get into the building and get some thermal imagery of these things, and then you put it in your report and you let the client know, hey, this is a real deal. Those windows, you've got 100 degrees is your hottest point coming through that window. You might want to think about changing those 50-year-old windows out. Low-hanging fruit, obvious, but the people that are writing the checks for these things, they want to see it come from an engineer. They want to see it in a report. They don't just want it. They're not just going to do it because somebody mentioned it. So sometimes there's some really easy payback stuff that you can do just by putting it in your report. This was interesting, thermal imagery, just because when we were going through our modes for heating and cooling. You could see that even though it's supposed to be in heating mode, we see it's not heating, but we can take a thermal image of it and see that the coil is actually the coldest part of the terminal unit right here. It just makes sense when you've got all that cold air blowing through it. Here's a test I was talking about. So one of the tests that we did, again, we do very detailed test scripts when we're going back and doing this. And as Travis mentioned, we want to not just write a test script, but we want to include all the modes, and we want to have a plan and an approach when we're coming in to test one of these labs. And so we'll write a detailed test script for a lab with 1 fume hood and a different one for a lab with 12 fume hoods. Make sure we're going through all the sequences, doing it appropriately. What was really cool about this particular project is that the client kind of wanted everything live. And at the time we weren't using Facility Grid or CX Alloy. And so what we did is we went ahead and we used Google Drive, and we put this in an Excel spreadsheet online and gave them access so that they get in there and see our live readings, see what we were doing. And they wanted that glass door. They wanted to be able to see what was going on. So we gave it to them, and it was really, really easy to do, and they never logged in and checked it out, but they wanted it. We gave it to them, and it was really easy. And it was the same thing with the issues log. We kept the live issues log going, so we post that stuff up online. They can see exactly what the issues are, and we're talking about the small stuff, the little installation things, and it adds up. You get into an old facility, and you get hundreds and hundreds of small issues, and they add up. It's the big issues that really count. Just a thermal image example of rooms fighting each other. Pressurization diagram, this was the analysis. This was our deliverable when we did our pressurization analysis. This was the proof. Hey, here, your building is negative. This is where your moisture's coming from. We've got negative readings at all of your doors. And what we did is we looked at the design air values, and then we looked at the most recent tab values that they had done just within the last few years, and we proved it to them and said, your air balances for your entire building are way off. You don't have enough air coming into your corridors. Your labs are just creating negative corridors. You're bringing in air from outside, and proof's in the pudding right there. And so it was really easy to develop something like this. A lot of times you'll see this in a really good design drawings on a new project, new construction. You'll see this in the drawing showing the air balance and showing how the pressurization is supposed to be, when you get a really, really thorough designer. Same type of deliverable. Easy to put together, cool to put together. The client loves it. I mentioned all those issues that we were posting online and keeping the owner up to date with what was going on and the things that we were finding. And that's great. And those are things, what we typically do is we'll tag them with, is this something that your O&M staff should be able to just go in and fix? Is this something that's big and it's going to take a contractor to come in and fix? Is this something that we can fix on the fly? Sure is, and we did. We keep those items all running on that log so they can see what's going on. But this is your bang for the buck. This is really what they're getting out of these projects. The ECMs and the FIMs, the FIMs, it's energy conservation measures, facility improvement measures, if you're not familiar with those. Essentially, these are the big things that you need to implement to either get major energy savings, or FIMs are for, this is just to make my facility work. In the case of the one building that was raining, they're FIMs, because if you guys don't do this, if you don't fix these things, it's just going to continue to have these humidity issues. But a lot of times what we're in it for is to find energy savings in these facilities. So when we can find those energy savings and we can identify exactly what they have to do, what kind of control setbacks, what do they have to fix, do they have to go back and retab the whole building, and is that going to be enough? Is it go back and recalibrate these sensors? Is it fix all your DDC controls here, or replace this old Falcon system that is out of date? No matter what that is, we're going to go through, identify that, and then we're going to try to put a cost to it. And that's probably the most difficult part, especially today. Construction costs have just gotten really, really volatile. So that you got to be careful here where you're trying to put a cost to these corrective actions. And a lot of times you want to have like a certified cost estimator do this, or a lot of times we'll try to get a contractor. If the owner has a contractor they like to use, we'll try to get them to give us an estimate or something so that we're going in with some realistic costs. I know that we did one of these in one of these laboratories, and right before costs kind of started to soar, And so we had to keep going back and working with the contractors to figure out how we were going to get some of this stuff accomplished. But the whole idea here, especially with the energy conservation measures, is we're trying to prove a return on investment. We want to show these guys, hey, if you do this, this, and this, it's going to save you all this money, and it's pretty much going to pay for itself in 5 years. And the whole point is, a lot of times they'll go directly to the department. So in a chemistry laboratory, they're going to go to the chemistry department and say, hey, you can invest this much, and within this few many years, you're going to get your payback on this. And that's really what sells the whole project, to get this stuff done and get these facilities fixed and running right. So these are your big deliverables, your ECMs and your FIMs. And then again, like I said, what we'll do is we'll provide a final report that includes all of this stuff, details everything, and we like to present it to the client, do a big presentation, a final wrap-up meeting, show them everything. And what's really funny is despite anything that we might find in the lab, they're like, oh yeah, you're very technically proficient, you found some good stuff, that's cool, and way over our heads. What they're most grateful about is what Travis was talking about earlier, the coordination, going in, working with their staff, and they're like, wow, you went in there and you did all of this work and provided all of this, and we didn't get any complaints. And that is like the biggest thing. That's what they really care about. They didn't have their researchers complaining that we were in their spaces doing all this stuff for 2 months at a time. It was about the best compliment they had to give us. So, and with that is what we've got. Thank you very much. Really appreciate it. Anybody have any questions? Right here, right up front.
Everybody loves those energy savings, and the money is great, it's important. But how important were the FIMs? Being able to say, well, now it's a safer place, or now it's less likely to break down. How important were those in the decision making?
They're at the top of the list. So both labs. Yeah,
Typically
both
in a
labs.
lab space, yes.
Yeah.
Yep. They want their tenants to be as safe as possible. And if a lot of times the tenants are seeing their fume hoods alarm, so they know that there's an issue. They just don't know typically how bad it is most of the time. So when you've got a PE stamping a report saying, yeah, it's pretty bad, the university really jumps on board to get those fixed.
Yeah, it seems like the energy conservation measures almost always come secondary.
Yep.
We almost always have 2 or 3 great big FIMs that it's like, you pretty much got to do this to get your facility working. And those go right to the top of the list. In some cases, we find some life safety issues. Those go straight to the top of the list. In fact, a lot of times they'll find funding for those that is completely outside of the project.
Yep.
When they see something that's life safety, they simply go, okay, well, hand that off to these guys and get it done yesterday.
And a lot of times also if it's a live project, like what Rob was showing you where we showed our clients our live work, if they get in there and they do see something early on, a lot of times they're in there fixing it before we're even finished with the facility, if it is a big enough issue.
Which is why they want that live issues log.
Exactly.
Right over here.
Talk again, if you would, about your process of determining how they use the labs and the diversity of the use and those types of things.
Okay, well, couple things that we do. Number one, when we get everything, we know the renovations, we get an idea of what the labs are used for. Specifically, we know this person's this department, they do this, but it's all a part of that initial walkthrough. When we walk through with the owner's PM and we talk to the individuals running the lab, we talk to them. We ask them what their issues are, what they're doing, what kind of chemicals they're using, what kind of processes they're doing. And Travis also mentioned the occupant surveys. Some of these people, they're a little bit like engineers. They're somewhat introverted. And they don't necessarily want to come and talk to us, but they will fill out a survey and give us some good information that way. And so that's another great way we can get in there and figure out exactly what it is that they're doing and find out what some of their bigger problems are.
So you mentioned earlier that the second floor, they had to replace 100% of the ceiling tiles. Did they have any other issues with like light fixtures, wiring, things like that, or is that another presentation there?
Well, there certainly were some light fixtures that were affected by all the moisture and everything coming in.
I don't think they actually replaced any. I think they were able to drain the lights out and clean them up enough. But I don't think they actually replaced anything, yeah.
There were a couple of places we know where the water came down and just in offices, and ruined stuff in offices like paperwork and things like that. We didn't hear of any research projects being completely ruined or anything like that based on this whole event, but it was more of a scare thing. The university was really worried that that's exactly what was going to happen. Something was going to get ruined if they didn't get this fixed right away. One of their big research projects was going to get ruined.
Yeah, I had a question. So when you were kind of qualifying the room, what they were using it for, these were just academic R&D labs, right? This wasn't like a preclinical or a clinical?
Correct.
Okay.
Yep, these are both universities.
Yep. Right here.
You had mentioned that you had a combination of DDC and pneumatic controls. I think at one point, did they
Yeah.
maintain the existing pneumatics, and if so, did you guys have to go through and recalibrate those and whatnot?
So when we first got in, there was some pneumatics still on the major equipment, on the air handlers, some water valves, some heating hot water valves. They actually had a ERU system that used glycol, and that was definitely still pneumatic. But as far as terminal equipment, they had just done a performance contract to change out all that pneumatic to DDC.
That was one facility. Both facilities had combination of pneumatic
Yes.
and DDC. The one facility, they were doing all the labs, but they weren't doing the major equipment. When we got done with it, they decided they needed to go back and redo the major equipment. The other facility, they had done DDC for all of their labs, and then in all of the admin and lecture halls and stuff, they had left pneumatics, but when we tested it, none of it was working. It was, leaky thermostats. Like, you could not go to a pneumatic thermostat and not just hear it hissing constantly. I mean, it was the whole facility.
I think we found one in a 100,000 square foot facility that actually worked. And that was, none of the other pneumatics worked. They were original. So. Go ahead.
Yes, sir, right over here.
Was the client willing to make the corrections before you proceeded on the rest of the report? Because I've run into DDC systems where sensors don't work, trends are not set up, and, you kind of stuck at that point before you can do any evaluation of meaningful data.
That's true. In one of the facilities, we had pretty good controls. It was actually two different control systems, one on the pneumatics and one with the DDC, but we were getting readings. I mean, if we found things that weren't calibrated or working correctly, we reported that, and then we were looking at, a contractor to come in and fix it. But we did not. What's that?
As part of your contract, or the owner's contract?
No. Our whole contract, it was purely investigation. It led to further contracts where a designer was brought on board. So for one project, the owner did not have an existing controls contractor or anything like that. So what we did is we looked at a series of projects to remedy our major findings, the things that the O&M staff couldn't fix. On the other project, they have a running contract with a controls contractor who they then brought in on our heels to fix stuff as we were going through it. They were the ones that wanted the live issues log because they wanted their controls contractor to be in there fixing things as we were finding them. Does that kind of answer your question? Okay. We didn't come across an issue where we got in and the controls were so awful that we couldn't even do testing. We did not come across that in these two projects. We have seen that in retro commissioning, yes. Yeah, if you completely need to do a full, renovation of your control system, we'd call that a FIM. There was another question in the back. Did anyone? You answered it. Okay, great. Anybody else? Oh, we got one right here.
Wondering, I work with some lab environments as well where the end users will tell us, some sort of contract stipulation that if we affect their research or their simulation or et cetera, how long would you guys stay on board as continuous commissioning or some other way to ensure that, hey, no, everything that we did and recommended didn't affect experiments or research so that can be pinned on you? Because that's
Interesting. Well, we did not have anything brought to our attention along those lines other than what were they doing at the? They had an energy contract going on with a big company that was going through and doing what do you call it? Performance contracting on like a dozen buildings on one of these campuses, and this project happened to be one that they had just gone through and done a performance contract when the issues started to happen, and they brought us in. And essentially, they were worried about us affecting something that was part of the performance contract. But our findings and some of the issues that were going on were enough to just say, wow, I don't know what you did with your performance contract, but you screwed our building up. So we got out of that one. Now, as far as the research goes, we did not have anybody that said, hey, we've got this research ongoing, and if you mess something up, that's going to be on you. We did not have anything like that.
When you're working with that ESCO, did you work with them close enough to help them recalculate savings or how their savings might be impacted?
Not specifically to recalculate their savings or anything, but more so to find out where they missed some stuff as far as didn't quite get it fixed.
We're actually still in the final phases of that project now, and working with that PC to help them kind of continue and get the building right.
Yeah,
Based
they're
off of
going
our
through
findings.
they're going through our issues log.
Yep. Go ahead, sir. Go ahead.
Well, just real quick, I just, as the gentleman was asking questions, I wasn't clear on the scope. It looks like, was the titles talk about retro commissioning, what you seem to have done assessment. Do you see retro commission always start with assessment? Are you following a standard, or actually a standard as to, for retro commissioning, we do the following? Do you see that? Is that what you all do?
Typically, when we're doing retro commissioning, it's following a lot of the same services that we listed here, where we start out by giving a general overview in our CX plan and how we're going to approach the building. But it's an investigation, and the process continues, but we can only fix a certain percentage of issues that we find as we're going through, but we need to have them on board. So for the most part, we're not going to go in and contract to go in and start fooling with their building. What we will do is we'll go in, and if we find things that just need to be worked, this damper isn't stroking, this actuator's broken, this valve isn't opening, their O&M guys can come in on our heels or with us and fix stuff and turn wrenches with us and get things working. But at the end of the day, the ECMs and the FIMs we usually come up with are kind of major overhaul or small renovation projects. And what they oftentimes need to do is get some capital funds to come back and do these things. And a lot of times it's not simple. They actually need to engage a designer. So now we are engineers, we're PEs, we can provide them with that service, but a lot of times what they'd prefer to do is find another design firm to design the fix, have us review it, see if we agree that, yeah, that's gonna get it fixed or not. And then they get a contractor, they fix it, and they bring us in to recommission it and make sure that it's working correctly and now that things are working. And that's kind of one of our projects is going through this whole thing with the ESCO company, and the other project is actually going through those renovations right now. They've gone through the design phase, and they're like at 100% design on renovations, and it's like a 5-phase renovation for that lab that they're just getting ready to bid out and contract and get those renovations implemented.
Do you know what the original EUI was for these buildings?
We did it on one. I don't have it offhand, but we did go back and calibrated it. Because in the CFR, a lot of times, if you're familiar with the current facility requirements, that's a big part of it. You go back and you do the energy benchmark, and you look at what the buildings are doing, and you meter the buildings and see how they're performing, what their energy consumption is right now, and then you go back and you benchmark against other similar buildings of similar age and et cetera, and you report all that. And so we did do that. Did we do a CFR for both of them? I think we did a CFR for both buildings. So yeah, I think if I dug back, we'd have the energy use index for both of those.
Do you have another one, or did I answer yours?
It's more of a curiosity question. I know you mentioned that you had, I think you, correct me if I'm wrong, you had variable volume, VAV inputs, right?
Yes.
Constant volume exhaust.
Yeah, neither exhaust system was constant volume. I'm pretty sure they were both variable.
Did I say that wrong? I might have said that wrong.
I don't think so. What was the question? Maybe I missed something.
Well, I thought I heard you said you had variable VAV fume hoods in the exhaust system serving those fume hoods with constant volume.
Oh, no. So what he was talking about, I think he's talking about the exhaust fan with the bypass. So yeah, our exhaust volume is variable, right? It's controlled off a static pressure sensor and everything, and then the exhaust fan up in the penthouse has a bypass on it. So the fan itself is constant volume to maintain that discharge velocity. It makes up the difference in the air volume through the bypass. That's what he was talking about. It was pulling the air in through the penthouse.
That was just for the stack velocity.
Correct.
Yes, exactly.
They maintain that stack velocity. That's pretty common. Anybody else? All right, I think we are like just about out of time, so that wraps it up. Thank you very much.
Thank you.
Really appreciate it. Great questions.